Okay, let us start our discussion on principles of compiler design. As you already know, this is our first lecture on the topic. This course is a core course in your PG degree, and we have to understand the underlying concepts of compiler in this particular course. At the end of this semester, as learners, you should be able to understand the fundamental concepts of compiler design. And you should also understand how a compiler is designed and how different modules of a compiler will work together to produce a target code. We will skip these portions for the time being. Now, let us see how the modules are arranged in this topic. In Unit 1, introductory concepts of compiler, followed by a discussion on lexical analysis is being done. Unit 2 is about syntax analysis. In Unit 3, runtime environments is being discussed. In Unit 4, intermediate code generation will be discussed. And in the fifth unit, we have code generation and code optimization phases of the compiler. Hence, all these 5 modules taken together will give us a brisk walkthrough compiler design. Let us start with a quick introduction. Let me ask you, what is a compiler? The term compiler is not new to you. We have learned about compiler, or we have heard about compiler in our programming classes, in our system programming classes in UG days, and in the operating system class you might have learned about that. In the art of programming methodology class, in which we discuss about the programming fundamentals, there also we have mentioned about compiler. What will be your quick answer, being undergraduates of computer science and students of PG students of computer science? Just pause the video for a few seconds and think about that. How well you can precisely answer this question. What is a compiler? Okay. We can quickly say that a compiler is a translator. What should be translated? What is being translated? What's the need of translation? And what is the input for this translator, and what is being produced? These are all the immediate questions in one's mind when we say that there is a translator called compiler within a computer system. So hence we can elaborate this particular definition as follows. Compiler is a black box which can accept our higher level code in a higher level language, source code in a higher level language will be taken as the input, and the compiler produces the machine code for a particular machine architecture. Again, we come back to you. Why we have to learn this? If you look at the syllabi and curriculum of all major universities in the world, you can see a flavor of compiler design both either in the UG or in UG curriculum. At least it's a module in undergraduate courses and a full-fledged course, even supplemented with practical hours in several PG courses. Why compiler design is included as a core topic like this? Do you have any answers? Do you have any wild guess of this? The first reason is that being computer professionals, we have to know about our tool, and that's it. Programming, at least for programming students, students of computer programming, compiler is a prime tool. We have to know about this tool. And many of the techniques that we learn in compiler design is applied in other related courses or in topics of computer science. And we can also see that compiler design is a major project work whose study touches upon programming languages, machine architectures, and even language theory algorithms, and lastly, software engineering. See, all these are all big areas. Concepts of programming language, machine architectures, language theory algorithms, and software engineering. A good compiler designer has to know about the language in which he is going to translate. And believe it, fundamentals of programming and programming language techniques is a course itself in computer science curriculum. Machine architectures deals with the architecture of the CPU. Target code is being made for the machine. Hence, the architecture of the machine is of high importance. Language theory algorithms deals with how to represent and manipulate a language in a way a program can understand. Remember that source code is the input for the compiler, and there has to be a mechanism to represent our source language either in C or whatever it may be. It should be well represented so that an algorithm can process that. Lastly, I told you that it's a big software project, and software engineering is about building a good project work. Now, so this compiler design study encompasses all these areas. Let us start with a small history. Since programming language is getting translated to the target code, developments of programming languages is all the more important for a compiler designer. How the so-called modern computer language that we see now were evolved. What was existing before. So we have learned in our primary days on computing that there are different generations of computers and how computers were evolved to this shape as we see today. In those early days also there were programming, but those programs are called as first generation programming languages. It was fundamentally binary languages.